Okay, so the x and the y-intercepts of a quadratic function, and we've talked about these a little bit, right? Like when does the x-intercept occur and so on. Complete the following, so factoring review. So in order to, one of the ways to find the x-intercepts of a quadratic function is by putting it into factored form. Okay, so we're just going to factor these guys. Review on factoring. So to start off by writing down two sets of brackets, right? And we know that when we multiply two binomials together, we use FOIL, right? It's going to give us four products. And so the first product, this x squared, only comes from what these two guys multiplied together, right? And the last product only comes from these two guys being multiplied together. So we need two numbers that multiply and will give us -6. Now, the way I think about it is, I think I need two numbers that multiply to 6, and because there's a minus sign there, I know that one is plus, one is minus, and that they're going to differ by whatever number is here. So they're going to differ by 1. So two numbers multiply to 6 which differ by 1, 2, and 3. Okay, so we put down a 2, and we put down a 3. And now we got to figure out which one's plus, which one's minus. So what we do now is we look at the middle term and we say the middle term's negative, and that means the larger number has to be negative. So minus and put down a plus. Okay. Now every time you factor, you should FOIL it out just to check, right? So just go x squared minus 3x plus 2x will be minus 1x minus 6. Right? And usually you're going to get the numbers right in factoring. Right? I mean, it's not too hard to find two numbers that multiply to 6, but oftentimes what will happen is you might get the signs wrong. Okay? So that's why you want to check it out. Just make sure, because a lot of times you'll put a minus there and a plus there, and just FOIL it out. Make sure you get a -1, and then you get a -6. Okay, here, this one. So again, two sets of brackets. It's got to start with x and x, right? It's the only way to get x squared. Now I look at the last term, and it's a 6. But it's positive, which tells me that both signs have to be the same, right? The only way we get a positive last term is to multiply two positives together or two negatives. So in this case, which is it, two positives or two negatives? Yeah, so now we look at the middle term, and it tells us which. If this was a negative middle term, then we know that both numbers have to be negative. It's the only way they're going to add. Right? Because the middle term is the sum of the outer and inner, right? Minus 3x plus 2x. So in this case, since it's plus, put down plus, plus. I need two numbers that multiply to 6. Since the last term is positive, they have to add up to the middle term. So two numbers multiply to 6 and add up to 7, 1, and 6. Okay? Doesn't matter which one you put where, but check it out, right? X squared plus 6x plus 1x is plus 7x plus 6. Okay? So just do it in your head. You don't need to, you don't need to FOIL it out on paper, because you know what you're aiming for, right? This is what I'm aiming for. I just want to make sure I'm going to get it. X squared plus 6x plus 1, yeah, that's 7 plus 6. X squared plus 6x plus 9. So this could be done two ways. One way is just the way we did the other one, right? You're going to start off, just each one leads with an x, x, and x. That's a plus, and the middle one is a plus, so I can just fill that in, right? It's x plus something, x plus something. Okay, so I call that factoring by a pattern of signs, right? Which is I'm looking at the sign of the last saying, hey, that's negative, I need a plus and a minus. Hey, that's positive, and so is that, they're both pluses. And this one here is the same. So two numbers that multiply to 9 and add up to 6. 3 and 3. Okay, and you could check that out, right? X squared plus 3x plus 3x is plus 6x plus 9. Another way you could do that is to say, hey, that's a perfect square, right? So maybe this is the square of a binomial. Okay, so if you recognize that, then you can just say, okay, the square root of 9 is 3, and if I double that, I get 6, so this is really just x plus 3 quantity squared. Okay, doesn't matter how you write it. You can write it as x plus 3 times x plus 3, or x plus 3 quantity squared. This one, we want to do a little something first, which is what? We want to take out a 2. Okay, so it's called common factoring, right? The very first step in any factorization is always a common factor first. And that's to just say, hey, I got a 2 there, and that's even, so 2 divides into all of these, so it's 2 times x squared plus 7x plus 6, which we already factored, right? So then it's 2, and then x plus 1, x plus 6. Questions? What are we going to do here? Take out a 2, but what else? What's common between the two terms? 2x. So we take a 2x. So what's left? Okay. Now, when you common factor, in the brackets, you're going to have as many terms as you had originally. Right? Because the idea is I need to expand this back out to get 3 terms, so I've got to have 3 terms here. This has to expand out to give me 2 terms. There has to be 2 terms in the brackets. Okay, and then just check it, right? So 2x squared plus 10x, okay, done. Right, there's nothing else you can do. This guy, what's special? What do we call that? Difference of squares. So to factor a difference of squares, we put down 2 brackets, right? 2 sets of brackets. We take the square root of the first term, which is x. Okay, so again, just think about it. The only way we're getting x squared is to have x times x. We take the square root of the second term, which is 5, and we write it down once as plus 5, and then minus 5, right? Because I need to get minus 25. So plus 5 times minus 5 is minus 25, half second.
Does it matter where you put the?
No, but I always put it last. Okay. So x squared minus 5x plus 5x, well, minus 5 plus 5 is 0, minus 25. Okay, so difference of squares and basic trinomials. That's stuff you're going to need to know in 30-2 as well. Okay, so you do need some factoring skills to carry through 20-2 and into 30-2. 30-2, not a horrendous amount, but just difference based, and what you see up there, that's what you need to be able to do. Okay, so if you have any factoring problems, I think we talked about this because we did some factoring in the warm-up stuff. Just go through, go find YouTube videos or go on Khan Academy, just basic factoring, right? You just want to be familiar with basic factoring. You need to be. Wow, my smart board is actually on now. Using simplified and factored form to find it. So it's kind of like, why do we factor, right? In 10C, we factor for the pure pleasure of factoring, right? I mean, we don't actually go anywhere with it. We just factor as a skill. But now, why? Because you can use the factored form to find the x-intercepts. Okay? You can use the simplified form to find what? The y-intercept. The only thing this form is good for is finding the y-intercept, right? You can just read it off. What's the y-intercept here? 6. What's the y-intercept here? Minus 5. Okay, you fill in the rest of the y-intercepts. And why is that, right? Because the y-intercept occurs when x is equal to 0. You make x 0, it's going to wipe out any term with an x. You're just left with the constant term. So this one's pretty, straightforward for y-intercepts. No bit. What's this one though? If I make x 0, what am I going to get here? 0. Okay, and even though this factors, the constant term is still negative 48, right? So you say, hey, but they're all divisible by 4. Yeah, for the y-intercept, doesn't matter, right? You're just taking the constant term. That's how you find the y-intercept. Remember, y-intercept is a point on the y-axis. What's the x value when you're on the y-axis? Right? You're not going left or right, 0. Okay, x-intercept occurs when the y value is equal to 0. So What's useful here? Well, the factored form is the form we want to find x-intercepts, right? Because what we want to say is, okay, what value of x is going to make this be 0? So what value of x can I put in here so the whole thing will work out to be 0? Positive 2, right? I put a 2 in, 2 minus 2 is 0. I don't really care what this works out to because 0 times anything is 0. So x-intercept. So 2 or 3. Okay, so the the x-intercept occurs when y is equal to 0. Looking at the factored form, you have to say, what value of x is going to make this whole expression 0? And then we break that down and just say, fine, what value of x makes that 0? 2. What value of x makes that one 0? 3. What value of x makes this 0? Negative 1. Positive 5. Do we put brackets around these guys? No, right? Because an x-intercept and a y-intercept are just numbers, and so 2 comma 3 is just a list of two different numbers, right? Because you got an x-intercept at 2, you got an x-intercept at 3. Okay, this one? And negative 4. Now, you can, if you like, you could write them in numerical order, right? So lowest to highest, put the negative 1 and then the positive 1. It doesn't really matter. Okay, just so long as they're both there. There's only 2 of them. If I'm marking it, I can kind of figure out, right? I just need to see both of them. This guy? Negative 3 and positive 3? What makes this 0? That give me a 9. That give me negative 9. 3 times what gives you 0? 0. What makes this 0? 5. Okay, so when you see the variable by itself, right? So it's like the thing we factored back here, right? 2x times x plus 5. When x is 0, then y will be 0. When x is negative 5, y will be 0. So these guys are a little more obvious, right? Negative 1, 6. This one's a little too easy almost. Which makes it kind of harder. And then for this guy, negative 2, positive 6. Yep.
I was just wondering, how come you would have multiplied it out and then you would?
If I multiplied it out, I'll be back into standard form. What's the only thing standard form is good for? Finding the y-intercept.
Okay.
So here's what's going to happen. If I give you standard form and say, tell me the x and the y-intercepts, you look at the standard form, you get the y-intercept, and then you say, all right, now I need to get factored form, because factored form is easy to get the x-intercept. If I give you the factored form, that's easy to get the x-intercepts. If you want the y-intercept, you're going to have to multiply it out. Now, in a sense, you don't really have to multiply it out. You can just put a 0 in for x and go 4 times 2 times negative 6 and get negative 48. Okay, so if you want to find the y-intercept from this form, you just put a 0 in to say it's positive 3 times negative 3 is negative 9. It's negative 1 times positive 4, which is negative 4. Okay, so you don't really need to go to standard form, right? Like you don't need to. But you do need to take standard form down to a factored form in order to find the x-intercepts. Examine the table above and examine the table carefully and complete the following statements. Okay, so you should do that. Go ahead. Do everything in pencil, right? And have an eraser. So take a look at the table, figure out what should go in there. So in this case, we're moving from the specific, right? You have like 6 or 7 specific examples, but we want to come up with a general statement for it, right? So specifically, all right, x is 1 and x is negative 4. But in general, if the equation of the quadratic is in the form y equals x minus a, x minus b, then the x-intercepts of the function, x-intercepts of the graph of the function are, okay, what goes in the blanks? A and B. Right? Because if you go A minus A, what do you get? 0. If you go A minus B, what do you get? You get A minus B. But you're multiplying it by 0, which gives you 0. If you put a B in there, you get B minus A, which is, I don't know, some expression, but I get B minus B, which is 0, and then the whole thing works out to 0. If we go the other way, if the x-intercept of the graphs of a quadratic function are A and B, then a possible equation is x, what goes in here? Minus A, right? Because if I put an A in there, I'll get a 0. And x minus B. Okay. So all we have to keep in mind is when we do this for real, right? If I say x plus 5, then you're going to say x is negative 5, right? So, if it's x plus 5, we can write that as x minus negative 5, right? That the value of A is the value that follows a minus sign. That's way too much thinking, right? You just say, what value do I make this so that this thing becomes 0? Right? That's a little bit easier because you can do that without thinking. If you see x minus 5, you don't have to think about it. Say, I put a 5 in there. Without using a graphing calculator, state the x-intercepts of each of the following quadratic functions. Okay, you can do that. I'll give you a head start. I'm going to pause. Okay, yes, no, maybe so. They're all good? Okay. Easy? Yeah, easy peasy, right? The hard part is changing the standard form to factored form. Once you've got the factored form, finding the zeros is pretty easy, right? And the factoring, it's not as difficult as you think. Just make sure that you check it out. That's the biggest thing, right? It's like, oh, wait, I get a 7 in the middle instead of a negative 1. I shouldn't be using 1 and 6. I should be using 3 and 2. All right, here we go. Without using a graphing calculator, determine each of the following. All right, x-intercepts. So should we just do all of those first? That's pretty easy, right? So do the x-intercept. You are now certified x-intercept expert, or x-intercept finders at the expert level, right? Okay, are the x-intercepts good? Y-intercept. Now, if it doesn't ask us to find the standard form, then we don't need to in order to find the y-intercept, right? What do we do to find the y-intercept? You set x to 0, which gives you positive 2 times negative 5, which is negative 10. You do the rest.
Shouldn't that be positive?
Which one?
Negative 12.
Negative 12. So I have negative 3 times negative 1, which is positive 3 times negative 4. Generally, when I make mistakes, okay, put it this way. If I do it on purpose, I usually pause and wait for somebody to find it. Most of the time, they're not on purpose. I just make mistakes. So. Okay, the equation of the axis of symmetry. I gotta take it back to yesterday. Sure, okay. How do we do that? What do we do? Remember back to yesterday, you'll say, oh, well, what I want to do is find the average of what? Right? I know the x-intercepts, right? I know the axis of symmetry is exactly halfway between any 2 points on the same horizontal line. What's the nicest horizontal line? Nicest horizontal line is the x-axis, right? So if I know the x-intercepts, then I know that the axis of symmetry is halfway between these two guys. So it's negative 2 plus 5 let's write that as 3 over 2. Right? If you like, you may think of that as 1.5. Right? So if you had to graph it, you put x as 1.5. That's fine. If it works out to like 4 over 3, leave it as 4 over 3, because 4 over 3 is exact, and if you try and go to a decimal, you have to round it, and that's not exact. Okay? So in general, leave it as a reduced fraction. Okay? Now, you work out the rest. What? It's a nice, okay, so if it's a nice fraction like 3/2, if you write 1.5, no harm, no foul. If you write 2.5, yeah, whatever. You write 5.5, okay. But if it's like 2/3, you can't really write that, right? Unless I say rounded to the nearest. If I say rounded to the nearest 100th, then you know I have to take 2/3, change it to 0.67. Okay? But 2/3 is exact, and anything else is just some rounded value. Coordinates of the vertex. How do we do that? Think anybody do anything yesterday? Good. Remember I said half the battle is, okay, half the battle is showing up, the other half is just doing a little bit of homework. So, what do? I have to do some calculation. What calculation am I going to do to find the coordinate of the vertex?
Wait, do we put it in our like the y equals, like in our calculator?
You could, but that's a little bit too much work. What do we do with this?
Put it in for x.
Yeah, you put it in for x, right? What is this? This is the equation of the axis of symmetry. It is also the x coordinate of the vertex. So we know the vertex occurs when x is 3/2. What's y? Well, this is y. Y is equal to, so we're going to have to go 3/2 plus 2 times 3/2 minus 5. I'm going to actually show the work here, right? Okay, so we're going to go y is equal to 3/2 plus 2 times 3/2 minus 5. Now, if you show that, it at least says to me, yeah, okay, you know what you're doing, right? And then if you want to plug that into your calculator, just, don't make any mistakes when you're doing it. But, so I'm going to go 3/2 plus, so I need to change 2 into halves. So 2 is 4/2, right? And you got to multiply it to 2 by 2 because I got to change it into halves. And what's 5? How many halves are there in 5? There are 10 of them, right? So this is 7 over 2 times negative 7 over 2, which is negative 49 over 4. Okay, you will find that at negative 12.25. So if you graphed this, right, and if you want to graph this, you can just do it like this, right? You don't have to expand it out. You can say y1 equals bracket x plus 2 bracket x minus 5 bracket, hit graph, adjust your window because this is going to be down below, right? We know it opens up because we got an a value of 1, right? Like a positive leading term. This is x squared, so we know it opens up. We have a negative leading term, we know it opens down. Okay, so if you did that, you could graph this and check it, and you just see it at negative 12.25, right? It's not going to give you negative 49 over 4 on your calculator. Okay, same deal here. So what do? We put in 0 for x, and that gives us what for y? We already know. So negative 18. So in this case, the y-intercept actually is the vertex, right? Oh, so this wants the coordinate of the vertex. Hang on, I'm going to move this stuff up. No, not one piece at a time. So it's 3/2 negative 49 over 4. Right? Again, what do we want? We want reduced fractions. Okay, so 49 over 4 is a nice reduced fraction. If you wrote negative 12.25, I'm okay with it, right? It's a big deal, right? Because it's exact. So you could go 1.5 comma negative 12.25. Cool, it's exact. If you end up with 3's or 6's in the denominator, you want to leave 3's or 6's in the denominator. Okay, this guy here, vertex is at 0, negative 18, right? How do I know? Well, I got to put in a 0 into there. I already did that, right? That's how we found the y-intercept. Put a 0 in. Okay, so there we go. It's at 0, negative 18. This one, yeah, not so easy, right? We gotta. So I'm just gonna write smaller. Okay, so do this for me, right? If you're gonna do this, write that down. Then if you want, just plug it into your calculator, work it out, come up with the number here, then give the coordinates. Okay, so this is just showing, see, look, I know what I'm doing, right? I know that I have to put in the x coordinate of the vertex, which is what? Well, that's the equation of the axis of symmetry, gives me the x coordinate for the vertex. I'm gonna put that into the expression, and it's like fractions and stuff. You know, you don't need to see me work it out. I'm just going to work it out. Okay, now, I'm just going to work it out. So that's negative 3. So we got 5 halves times negative 1, or minus 1, which is 3 halves. And we've got 5 halves, which is negative 3 halves. So that's a negative times a negative is a positive. 3 times 3 times 3 is 27 over 4. So 27 over 4. And the coordinates of the vertex are 5 over 2. Okay. Now, somebody hopefully has checked this out, or else this just is wrong and whatever. Actually, I can check it. Let me check. Which one is that? It got cut off. They said 6.75. Okay, 2704 is exact, right? It's 6.75. It's okay to write it as a decimal.
So it's okay to not write it in
It's okay to write it as a decimal, right? As long as it's an exact decimal. So if you've got like the 0.33333 going, unless it says give the coordinates of vertex rounded to the nearest hundredth, okay, then you can round.
Okay.
Okay? All right. Do you think you can do the last one? Okay. So use your calculators to work out the fractions. It's fine, right? All I really want to see from you is kind of like this line here, and then like this, and then like this, right? Just show me what you're doing. I want some communication. Okay, look, I know that I have to put in the x value from the axis of symmetry because the axis of symmetry passes through the vertex, which means the x coordinate of the vertex is 5 halves. And if I want to find the y value, because this is really y equals, right? Any of these guys are, you see p of x, g of x, f of x, they're all y equals. Okay, what's y? Well, y is equal to this. What do I want to know? I want the value of y when x is equal to this. So I'm just showing that here. Look, I'm substituting in the x value of the vertex. When I work it out, I'm going to get the y value of the vertex. And just do a little practice. Determine the equation of each of the following quadratic functions. Okay, so this one is given the graph. Okay, so I've got the graph. So I want to look at it this way, and I'm going to say, all right, here's the thing. We know that if I wrote this in factored form, it would look like this. Y is equal to now some number, right? We don't necessarily know what that number is, but this thing could be stretched. Okay, that's why we put that A. Oh, I shouldn't use A in both places. So, all right, let's. So that's kind of a general factored form, right? Y is equal to A times x minus b, x minus c. So what we can say is here, well, look, we know the x-intercepts, right? The x-intercept is x minus 5. So what do I write here as a factor? So if I put a negative 5 in here, I want this thing to be 0. So what do I need to write? X plus 5. And I know that an x-intercept is 3. So I want to write an expression, which if I put a 3 in for x gives me 0. So what am I going to write? X minus 3, right? So you got to think of it as it kind of goes backwards, right? The x-intercept is 3, the factor is x minus 3, right? So if I put a 3 in here, I'll get a 0. The x-intercept is negative 5, the factor has a reverse sign, right? Because I need an expression that's going to give me a 0. And now what we do is we look for another point on this graph. So we try and pull something out. I mean, what did they use? Okay, so you see here negative 15. We've got this point on the graph, 0, negative 15, right? We know the y-intercept, or we can read the y-intercept off the graph. So what do, right? We say, all right, I'm writing a general factored form for this because I know what the zeros are, right? I know the x-intercepts. I can plug the x-intercepts in here, and now what I want to do is take a point that's on the graph, and I know that when y is negative 15, that x is 0. Oops. Okay, so that's x, that's y. So when x is 0, y is negative 15, and we get negative 15 is a times negative 15. So what's a? Zero.
1.
Negative 15 times 0 is 0. No, 1, right? Okay, so the equation is y is equal to 1, which you don't really need to write. Now, did it say what form to write the equation in? Determine the equation. No. So we can leave it like that. You generally would not write the 1. Okay. If it wanted it in standard form, you'd multiply this out, right? It'd be x squared plus 2x minus 15. You just FOIL it out. But that's good enough, right? That's a factored form equation. So here, this guy is stretched, right? Because if I move 1, I would normally move 1. So I know there's an a value which isn't 1. Plus it opens down, right? Which means the a value has to be negative. Okay, now we can identify, okay, so we've got the x-intercepts and we've got the y-intercept, right? That's 0, negative 6. So we say, all right, I'm going to start with a general factored form. Okay, because I've got the intercepts, right? And I'm going to substitute in, okay, so x minus or x plus, what? How do we deal with this guy? X minus 1, right? Because if I put a plus 1 in, which is this, I'm going to end up with 0. So x plus 1, oh, sorry, x minus 1, and x minus 3. Just think of it as they have the opposite signs, right? That's all I think, right? So if the 0 is 1, I need to write x minus 1. Because then I put a 1 in there, and if you want, then go back and just, okay, if I put a 1 in, yeah, I'll get a 0, good. If I put a 3 in, yeah, I'll get a 0. Okay, let's put this in, so negative 6. So since we know the y-intercept, we know that when x is 0, y is negative 6. And we get negative 6 is equal to, okay, we got negative 1 times negative 3 is positive 3. So we get negative 6 is equal to 3a. What's a?
How do you get
0 minus 1 is negative 1. 0 minus 3 is negative 3. Negative 1 times negative 3 is positive 3. So a is? Divide both sides by 3, and you get? No, you get negative 2. Okay, what do we do? Now we go back to here. Y equals negative 2. Actually, we go back to here, I guess, really, right? So now I know the a value. Now, you can check that, right? You're going to have time on the test to check that. How? You go in, you plug this in your graphing calculator, you set your window to look like this, and you see if they look the same. Right? So here, let's do that. I have the graphing calculator. Let's move it over. let's turn it on. I'm going to clear that. Y equals. Okay, I'm going to clear everything out I've got in y equals. Erase that. Okay, so -2. Remember, this is the negative you want, right? That's, oh, I'm graphing in y2, but it doesn't matter. That's a minus sign, right? That's the operation subtract. This is make it negative. So -2 bracket x minus 1. Okay, so I want that minus, not that. Close bracket, bracket x minus 3, x minus 3, close bracket. I want my window to match this, so let me move this up. Go back here. So I want to go from -1 to +5. Okay, -1, +5 by ones. And I want to go from y min, so like -13 maybe. -13 to +3. Also by ones. Graph. Okay, got an x-intercept at 1, I got an x-intercept at 3, I've got the vertex looking like it's about 2, 2, which is about what it looks like there, and 1, 2, 3, 4, 5, maybe 6, kind of hard to see. I can verify it though, right? Second count, value, put in an x value of 0, I get -6. Yeah, okay. Matches, right? So there you go. So you can check it, right? Like, this is what I think the equation is, I graph it, matches my graph. Okay, that's what the equation is. The graph of a quadratic function has x-intercepts, x equals, was there any questions on that? I could tell. X equals -2 and x equals 1. If the graph also passes through the point 2, -12. Okay, so really, this is the same as the last question, or same as questions we've been doing, just without a diagram, right? So if we like, we can draw a diagram. Passes through x equals -2 and +1 and passes through the point 2, -12. So does it open up or down? It's got to open down, right? Where's the axis of symmetry? Well, it's halfway between these two guys, right? I don't need the vertex, but could we find the vertex? Okay, not right away. We can certainly find the equation of the axis of symmetry. Then once we found the equation of the function, we could plug in that x value and we could get the vertex, right? If we needed to do all of that algebraically, we can. Instead, what are we going to do? Well, okay, these are 3 apart, so it's like 1.5. So it's, you know, somewhere up here, who knows? Okay, so there's a picture, right? How do we do this? Well, we know how to do this, right? We're going to start with a general factored form. We're going to fill in the x-intercept, so it's x, what do we do with that? X plus 2, right? Because I want this set of parentheses to be 0 if x is -2, right? And then what's the other one? This guy? -1, right? Because I want that parentheses to be 0 if x is 1. Okay, and then we say, hey, I don't have the y-intercept, right? Like I can't put it through. I don't know this point. But I do know this point. So as long as I know a point, I know that when y is -12, x is equal to +2. Right? When y is -12, right? So these numbers did not appear by magic, right? They're from the question, right? It says when the y value is when the x value is 2, the y value is -12. So I just go up here and say when the x value is 2, plug in a 2, the y value is -12. So -12. So that's 4 and that's 1. So -12 is equal to 4a. A is -3. Write it here. Y equals -3, x plus 2, x minus 1. How would you check that? Yeah, put that in your calculator. What do you expect to see? Well, I expect to have a 0 at -2 and 1 at 1. And if I extend my window so I can see, I expect the point 2, -12 to be on there, right? Okay? If you checked it, I'm sure you'd find it was correct. If I put a 2 in there, I get 4, 1, I get negative 4. Is there anything more? Is there more? Nope. Is that it? That's it. All right. Hey.